In these two sections of Algebra 2, we're going to be talking about a method of finding roots in the vertex without a calculator. That method is called completing the square, and I'll do a couple of examples of that. And then in section 5.2, we're going to be talking about the quadratic formula, which you became familiar with back in Algebra 1. We're just using it again. To use either of these methods, you have to recall that the standard form of a quadratic is ax squared plus bx plus c. The term we're going to be most concerned with while using the completing the square method is b. In using the quadratic formula, we're going to use all three letters, a, b, and c. A is the coefficient of x squared, b is the coefficient of x, and c is the constant term at the end. All of these can be positive or negative, so pay attention to the signs as you go. The main step in completing the square is taking the b, which is the coefficient of the x term, taking half of it, and then squaring that. So here, b is equal to 6. We'll take half of b, which is 3, and then square half of b, which is 9 in this case. So what we would do is write our equation in a new way. We would put x squared plus 6x in parentheses, and before we close the parentheses, we're going to take the half of b squared, which is 9, and add it inside the parentheses. To keep the equation balanced, however, we have to bring down the plus 4 and subtract 9. We're adding 9 inside the parentheses and subtracting 9 outside the parentheses. The next step is to write the trinomial x squared plus 6x plus 9 in a new way. We unfoil it and write it like this, x plus 3 squared, and then we take the plus 4 minus 9 and simplify that as minus 5. Let's do another one. This time, b is negative 2. And half of b would be negative 1. Half of b squared would be 1. So we take the x squared minus 2x. We're going to close the parentheses after we add 1, bring down the negative 7. Since we added 1 inside the parentheses, we have to subtract 1 outside the parentheses to keep the equation balanced. And then we unfoil the trinomial and we put x minus 1 squared, and we simplify negative 7 minus 1 is negative 8. Now let's do one, and I'll explain after I finish it why we are doing this step. Let's do 0 is equal to x squared plus 6x plus 2. b is 6. Half of b is 3. Half of b squared is 9. So let's write the terms with x in parentheses. Before we close the parentheses, we're going to add 9, bring down the plus 2, and since we added 9 inside the parentheses, we have to subtract 9 outside the parentheses to keep the equation balanced. Next step, unfoil the trinomial. We get x plus 3 in parentheses squared, and we simplify the plus 2 minus 9, and we get minus 7. The whole point of this method is that if we can write our equation in this form, with a binomial squared and then plus a constant, and we're going to call that constant k, then that form is called vertex form. This is known as the vertex form of a quadratic. In the vertex form of the quadratic, the letters h and k stand for your vertex. Now, the formula insists that we write the binomial as x minus h squared. But in the equation above, we have x plus 3 squared. That can be rewritten another way as x minus negative 3, because x plus 3 is the same as x minus negative 3. Okay, let's include the negative 7. Bring that down. And then identifying the vertex is really easy because we have our h value is negative 3 and our k value is negative 7. So you could conclude at this point that your vertex for this one is negative 3, negative 7. That's the vertex of our quadratic, and we can find that now without a calculator because we know how to complete the square. In the first two that we completed the square for and we got this far, I didn't identify the vertex for you, so I want to do that now. The first one that we completed in this video was parentheses x minus 1 squared minus 8. That means the vertex would be 1, negative 8. Since it's written in the form that we like, x minus h parentheses squared plus k, h is this positive 1 and k is this negative 8. The second one that we completed the square on back in the beginning of the video was the result, once we completed it, was x plus 3 in parentheses squared minus 5 is equal to 0. The vertex would be negative 3. X minus negative 3 squared minus 5. That puts it in the form that we like, x minus h squared plus k. So h in this case is negative 3 and k is negative 5. That's our vertex. Negative 3, negative 5. The vertex of the quadratic equation. Last thing we're going to do in these sections would be using the quadratic formula. we need to remember that the standard form of a quadratic is ax squared plus bx plus c. This method is used only to find the roots without a calculator. The quadratic formula is x is equal to the opposite of b plus or minus the square root of b squared minus 4ac, all of that divided by 2a. Before starting, some students like to write down what a, b, and c are. So let's do one where we have 3x squared minus 6x minus 1. Now remember, we're not using the calculator because the values that the calculator gives us are approximations only. We're using the quadratic formula because it gives us exact values. They will at times be irrational and at other times they'll be rational. So before we begin plugging values into the formula, let's write down what a is. It's 3, the coefficient of x squared. B, the coefficient of x is negative 6, and c is negative 1. Now we're ready to begin plugging in the values. X is equal to the opposite of b plus or minus the square root of b squared minus 4 times 3 times negative 1. All of that divided by 2 times 3. The more you work with this, the faster it'll go, but I always recommend plugging in the values first and then begin to simplify. The opposite of b will be positive 6. When we square a number, whether it's positive or negative, its result will always be positive. So negative 6 squared is the same as positive 6 squared, which is 36, minus 4 times 3 is 12. 12 times negative 1 is negative 12. All divided by 6. So we have 6 plus or minus the square root of 48 divided by 6. Before you start thinking about canceling those 6's, let's simplify the square root of 48. Because if you can simplify in all three areas, in this area, and this area, then you can simplify. But you have to watch for simplification in all three areas. So I've got, let me bring this up here. Look at the numbers outside the radical. 6, 4, and 6 are all divisible by 2. So we're going to divide by 2, divide by 2, and divide by 2. And our simplified answer will be 3 plus 2 radical 3 over 3 and 3 minus 2 radical 3 over 3. All right, just to summarize, those are exact values. They're not approximations. The calculator gives you decimal approximations of those.